Hi, and welcome to Jerry's Engineering Corner. My name is Jerry DiBattista, and I'm the Global VP of Porex's Virtek PTFE business group. Today we're going to talk about UV air systems. With the advent of the coronavirus and the pandemic, the issue of disinfection of air and surfaces has really come to the forefront. So today we're going to do a little demonstration on how well Porex Virtek works in disinfection chambers for air units. So for today's experiment, we are going to take some plastic pipe to simulate a duct within a UV air disinfection system. The first one we will do with just a simple piece of polyethylene pipe. What I did after that is I used a piece of reflective aluminum and of course our Porex Virtek sheet, and I lined two different pipes, one with the aluminum and the other with Porex Virtek PTFE. We will cap both ends. On one end we'll put a cap of either aluminum or PTFE, and then on the other end we're going to use a light-on high-intensity UVC LED which emits at 275 nanometers. To measure the amount of energy in the system, we are going to be using Intellego Technologies UVC detectors. These are small photochromic dots that will change color as it is exposed to UVC. And you'll see a color chart. The dots go from a yellow to a bright pink depending on how much UVC it absorbs. These ones are designed for 100 millijoules. So what we're going to do is we'll set up the tube here. We're going to put the LED source on one side. We have a little cooling fan here because it generates a lot of heat. And we're going to put half of one of the dots right next to the LED and the other half all the way on the other side to see how much energy is going through the pipe at either the front or the rear of the tube. Okay, first we'll start with the straight polyethylene tube. I'm going to take the Intellego dosimeters. I'm going to place one at the front and one at the very back. We're going to cap it with back plug. And then on this end, we're going to use the light-on LED. Okay, we're going to set the timer. So we're going to run this at around 6.3 volts, around 0.5 amps. It's going to be around 3.5 watts or so. And we're going to run it for 5 minutes. Okay, and we're going to turn on the cooling fan, because these LEDs do generate a lot of heat. So what we're going to do is after 5 minutes, we will turn off the power and check to see how much the indicators have changed color. Okay, we're almost at 5 minutes, and we will be turning off the power source here in about 5 seconds. Okay, that's 5 minutes. So now we'll take out the indicators and see what they look like. First, the one that's on the far end. As you can see, it's still yellow. And we'll take the one out of the other end. So you can see the color change, and you can see how the part of it's pink and the other part is still a bit yellow. So what's happening there is the LED, as it comes off at about 120-degree angle, not all of the indicator was actually hit with the light, and nothing was reflecting back in the tube, so the far part stayed yellow. Next, I replaced the tube with the one that's lined with aluminum, and we're going to take the indicators Same thing as before, we're going to put one right near the LED source, and we're going to put the other one in the back. We're going to cap the end. Put the LED chip in the front. And like before, we're going to start it and run it for 5 minutes. Okay, we're approaching the 5-minute mark. So we'll do the same thing. We'll turn off the power at 5 minutes. There we go. And we're going to check the indicators like we did before. Okay, the far end, you can see still fairly yellow, but there's a bit of a change on it. And then the one on the front end, you can see a little more uniform, still has a little bit of yellow on top, but it's much more uniform than without any reflector in there. And so the last experiment we're going to do is running it with the Porex Virtek PTFE. Okay, for the final experiment, we took the tube and we have the PTFE liner in it. We're going to take the indicators and we're going to put one on the front end, one on the back. Okay, and this time we're going to use a PTFE cap on the back to just make it consistent with the PTFE. We're going to put the LED chip on the front. And just like before, we're going to run it for 5 minutes and see what the indicators look like after 5 minutes. Okay, we're approaching the 5-minute mark. The excitement's building. Okay, and we're ready to turn it off. 5 minutes. Okay, so we're going to go take the cap off the end. And as you can see, this end, pink. And this end, you can see, fully pink. So as you can see, there's a small difference, but all the way down the tube with the Porex Virtek PTFE, you have a very uniform energy distribution. And so any kind of virus or anything in there you're trying to disinfect is going to be dosed very heavily with UVC, regardless if it's near the UVC source or if it's far away from the UVC source. So as you can see from the results here, in the plastic tube, which has very low reflectivity, the section near the LED source was very ununiform. You can see part of it was disinfected to about 75 millijoules per square centimeters. The aluminum lined one, more uniform. Again, you're getting some reflection, around 75 for the one that was close to the LED source. The one away from the LED source on the other end of the tube probably had around 10. You see a slight change from the yellow to just a bit closer to the 25 of the brown. But the Porex Virtek samples, as you can see, the one near the LED source was fully changed, so it was 100 millijoules. And the one on the very far end was 75. So this one at the far end of the Porex Virtek got as much energy as the one close to the LED source of the aluminum. So as you can see, having a well-lined reactor chamber is absolutely critical if you want to make sure if the product is completely uniform and any air going through is uniformly disinfected. So as my experiment today showed, if you are designing a UVC air disinfection system, you really have to use a highly diffuse reflective material to line your reaction chamber, such as Porex Virtek PTFE. The nice thing about Porex Virtek is that you can put the UVC sources really anywhere along the tube. The highly diffuse nature of the Porex Virtek PTFE really allows for a big margin of error, so the entire tube becomes uniform no matter the source. Well, that's it today for me, Jerry with a G.